Hi, everybody. It's a Wednesday, so this is first module 2. Remember, we're on the Wednesday to Tuesday schedule in this class. So a little different than in the past, but at first I thought it seemed really strange, but I think I kind of like the Wednesday to Tuesday schedule because then the weekend's in the middle and there's time to ask questions after doing our homework on the weekend. Or a lot of people in school have jobs where they have to work all weekend, like restaurants and retail. It's kind of hard to take a weekend off, so if the weekend's the last minute on everything, makes it a little difficult to get in. So it didn't take long until I started thinking I kind of like the new schedule, but I don't know for sure how long that's going to stick around or anything. One note that I want to start off with relates to the homework. Those who have had me in class before may have noticed something in the homework instructions seem to be missing from the way I normally give them. Several of you all did turn it in. Did you get this, Zach?
Yeah.
Okay, I'm going to erase this.
What was the code you said to type in the Chrome?
10.81.
10.81.
110.
10.81.
110.
110.
242. 242. That's what that's what a web address really is. And we just put words somewhere in the computer. We wrote a script that says, okay, these words mean the same thing as these numbers. And that way, that as humans, we can type words in. Did that pull up a page?
It's loading, but it hasn't went to it yet.
Okay, we'll see. We'll look at it here in a moment. So those who've had me before, some of y'all went ahead and turned this in. In the software development courses, that's what I teach most often. With the homework, I usually ask for a bug report, which does not have to be a big fancy thing. I just want to know how developing the software went. It's usually not an issue on week 1, but like, did you have trouble with what errors showed up? What did you do to fix them? Just a quick thing. It doesn't even have to be grammatically correct. Just some notes in the submission comment box. You can be like, everything ran on first try. That's good. Or the first try misspelled a variable name, had to fix that. Then did the math wrong, worked perfect on third try. It doesn't even have to be grammatically correct. I just want you to take a moment to review and reflect and and run a sort of a quick analysis on what you had just did. That's part of the learning process, right? The general 3-step process, the preview, the study, and then the review it to help sink it in mind. Yeah.
Did I type in the right?
That's what it was in the other one. Try this now. Maybe it will work. I'm not sure why it's not working there. We'll look into that later. But typically I ask for this, and those who've had me before in class, some of y'all turn that in. It shouldn't be a big deal. You can put it in the comments. Some people do that. Like as you put your code together, I've seen that quite a lot. Whenever you go back to fix a line, just put a bug report comment there. So like, oh, bug report issue, there was a typo here the first time. Worked on second try. It doesn't even have to be grammatically correct. I just want you to take a moment and reflect over everything you did, just to help make sure all the understanding is there. And if something like, if lots of people have the same issue showing up in the bug report, then I know to cover that in class. I know that needs more coverage. And I wrote the instructions, but forgot to hit save. So that's why they weren't on the homework thing. So I wanted to say something. So from the rest of the modules on the homework instructions, it'll ask for that. But just a small thing, you can write it up as a separate file. And yeah, I don't require much, but I have had some students that went ahead and we got on Google and downloaded like bug report templates. And just for practice in software development field, went ahead and did that full formal template every time. That way they, when they graduate and move into the field, they know how to handle that in the formal standard way for the field. But I just wanted a quick recap of how development went. Did it all work on the first try? Did you sit there and struggle and over again? And then if you're not able to get it to work, I can look at that bug report and kind of help narrow down, figure out what the problem is. Although if you're not able to get a program to work, you can always ask me questions. I'm always happy to help. There'll be instructions, but it shouldn't be a big deal. A small comment in the code or in the submission box, or if you want, go ahead and download formal bug report templates and include those in your thing. So this week will be should be an interesting week. Make our programs do stuff. I believe everybody that's in here has been through SDEV 120 before, so you have some familiarity with these concepts. So that first week was about some basic variables and just the simple math stuff, printing strings to the console, a couple little things like that. Then this week, the main content is going to be selection structures and loops. But I just wanted to talk a little bit about a few last little details that we kind of ran out of time for. So I wanted to talk for a while about IDEs, because having had the SDEV 120 class, everybody's had the basics there. So we just need the Python syntax, and then, like we saw the other day, there's lots of places where we can write our code that have tons and tons and tons of powerful tools available to help us get it together, get that code up and running very, very quickly. So, or really define problems when things go wrong. Because if things are going right, then it wouldn't really matter, right? We could open a simple text editor, and if everything works, that's great. But when things don't work, tracking down problems can be a bit problematic, and we saw a lot of the tools to help us do that the other day. I have to pull up these numbers real quick so I can sign in from my laptop for the last couple little notes. Join the meeting. Not connect audio. Okay. That'll work. So, I guess I'll start with something about strings. We're going to come back and see more of this later as soon as this pulls up. There it is. I should turn this down. Recording in progress. Oh. I clicked the don't use audio button, but I guess it did anyway. Okay, no feedback this time. So I'm going to go ahead and share my screen, and just a quick note about something with strings as we print them out that we will come back to a little later in the semester when we get to strings, so we'll see some better ones. But something we probably want to do, and we did a whole bunch of talking about IDEs the other day, and so people are using different ones. Lots of people looked at several different ones, made different selections. For class, I'm going to be using just a regular text editor. In particular, Notepad++, because I can zoom in on Notepad++. Most of our text editors don't have a zoom button. You can change the font size to make it bigger, but that doesn't behave exactly the same as the zoom button. So hopefully it can make it big enough to read on the screens and everything. So something that's gonna happen a lot is we might have a price. Going to grocery store, bring things out, we're writing a cash register program, and there's some item whose price is, or they're on sale for $3 for $10. So somebody only wants one of them, that price would be 10 divided by 3. And we want to print that out. We give them a nice little message. We'll print the price is going to be plus price. I'm going to throw an error here first, just a very common one. So I'm going to throw the error so we can talk about it, because it's probably the error that you get throw the most often. I've been using Python for decades and still do this all the time. Folder. Oops. That's not what I like to do. I'll save as keyboard.py. There we go, I'll leave that one. So there is a problem here. Some of y'all might recognize it. The string is going to be whatever's stored in the price variable. So first off, I like to see the problems. If we're looking at textbooks and tutorials, we see the finished version. Right? We see the code written left to right, top to bottom, no errors in it. So in class, I like to switch that up and kind of go over the way that we actually write code. This is one of the most common errors, because one of the things about Python is it's open type. When we go to store stuff in our variable, we don't have to say what type it is, but then that makes it so that data type is not fresh on our minds. So then when we have the wrong type somewhere, it's really easy to forget to change the type of data. So we don't have to say what it is, but Python does figure out what that data is. If anybody's using one of the IDEs that shows has a nice watch windows, variable explorers, when you store, well, in this case, this simple example, you would see the price is floating point data, not string. So when we go to do something with it, navigate to my delete folder. What's in here? Probably shouldn't match the keyboard if I'm going to try to use this. Example1.py. That'll work. Then I can remember what it is. I have a tendency to name files just by mashing the keyboard, and then I keep track of them by the date. I use the little date option and just try to remember when I did stuff. But sometimes that doesn't work quite so well. Example.py, so if I go and run that, is it not there? Oh, example1. Let me try that again. So out of the console, start the Python interpreter. And if you're on a Linux or a Mac, remember that the instruction is Python 3 instead of just Python. So start the Python interpreter and open example1.py script. And it throws an error message. Says type error. So that means somewhere the data was, we had the wrong type of data for what we were trying to do. And sometimes just interpreting error messages is a big deal in learning to program. Figure out what a message means, because that's kind of cryptic. In Python 3.10, that is one of the things they did, is there were actual professional writers, not programmers, come through and clear up the error messages. So they're much, much easier to read, especially for new people. But we can still kind of go through this. So a trace back means we looked at the last couple things. The problem was in line 5. That's what line 5 was. Can only concatenate string, not float in string. So even though Python's open type, we don't want to forget our casting. We do need to turn any numbers into a string. And now to the actual point I was trying to get to here. The price is going to be 3.3333333333. That's kind of an issue, right? That's not what a price looks like. So we might want to make that look a little bit nicer. So I was going to talk about some basic formatting. There's a built-in method with the language that is kind of just for basic formatting. When we get to strings, the string objects that we will work with whenever something is a string has the data type of string, there's a whole lot of better things we can do with formatting there. So we'll see that in a couple weeks, but for starting out at least, there's this built-in method called format. And it expects two parameters. The first one is the number we want to format. And then our parameters and arguments are comma separated. So things accept parameters and we send arguments. It's one of those little vocab terms that you want to make sure you commit to memory. So our format, and then we pass in a string that says how we're going to style that number, how we're going to format it. This just has some very basic ones. And at this point for us, we basically just need, they're probably going to be currency that we're formatting for homework assignments and stuff. And so what this looks like is instead of using this just cast into a string to turn that whatever floating point number is stored in RAM into a string and throw that out, we can use this format method, which will turn it into a string. Notice the prediction thing here. It's not in a good spot. You want to be able to see on your screen, it has star args, then star quarks. We'll talk about that later. That means it's open for passing things in. We could pass in lots of things or just a few things or nothing. In this case, nothing wouldn't work, but it's kind of open. So args are the single values. We have a bunch of things stored in a variable, we can send them in all at once, and quarks are and then it builds a list that we can access called args. And with 2 stars quarks, that's where we send in lists. So if we have lists and dictionaries and tuples that we want to pass into a function, or if we're building a function that we don't know what it's going to need, it's a good idea to add the args and quarks, but we will see that when we get to functions. Just a little preview on it since it showed up on the screen. Then we don't have to set explicitly what our parameters are. That basically means, okay, we're going to have some parameters. There might be single variables as parameters. There might be huge lists or dictionaries as parameters. We don't know. But if there's single variables, stick them in a list we're going to call args. And if there's a bunch of lists and collections passed in, we're going to stick them in a list called quarks. It's arguments and keyword arguments is what those stand for. But we'll see those shortly. So this is really just a method, an alternative method to turn something into a string. Usually we'll want to send in a number, and then how are we going to format that number? What are we going to make it look like? So our second parameter is going to be a string, and that's an easy one to forget. The way we describe it's always going to be a string. And then we need different symbols for how to format it. For currency, the one that we probably need most often right now, let's say a decimal point. So we're basically telling Python, just go through that number. When you hit the decimal point, write 2 more digits and keep it as a floating point number. So .2f will give us 2 spots after the decimal point. And there's different ways to format this string. So, and then we can just throw a $sign out front. So we include the $sign symbol in our original string. And then the number, we just want to put it with 2 spots after the decimal. So that's how we do that. So we'll come over and run that. It's really small. I can't zoom in on the prompts. But you can see it looks like money now. So that's something you're probably going to want in your assignments. And that's the most basic one. When we get to strings and when we have string type data, there's a whole lot of things we can do. Python is only an object-oriented for programming language.
I have a question.
Yes.
Why did you put a comma inside the parentheses and not a plus sign?
Here.
Well, inside the price, like inside the parentheses. Yeah, why is that a comma and not a plus sign?
So the plus sign wouldn't work here is we put an entire function inside of it.
I see.
It's got the name and then the parentheses, it has its own set of parentheses with it. So
Okay.
It's like a nested function. We nested the format function inside of the print function. And this question's shown up a couple times in emails about the commas versus the plus sign. So that only works on the console. And consoles, that seems a little out of date, right? We used to graphic user interfaces and a bunch of nice images that we can choose different fonts and not just print words to the console. So I always feel like that seems a little out of date, and that using commas for concatenation only works in the print function. Anywhere else, we have to use a plus sign for concatenation. So I usually try to avoid it because I don't like to print to the consoles anyway. I'm old enough to remember when we switched from pretty much everything was on the console to the first graphic user interfaces became popular. I saw the very first ones that when Windows 3 came out in 1991, 1992. I remember those days and moving from DOS to the very first Windows prompt. So I always feel whenever I'm doing things that print to the console, it feels like something that we stopped doing a long time ago. But we'll see graphic user interfaces very soon. It's near the end in the homework assignments, and we'll probably get a jump start on it and do that a little sooner. It's more of a modern thing, make things look a lot nicer that way. But that's the simple way to format things. Just call the format function, pass in the number, and for your homework, you're probably going to be doing currency, which would be 2 decimals. So you can just, if you want something like a temperature conversion, you only see with 1 decimal. The digit here shows how many decimals print out afterwards. Remember the point from the other day, always check official documentation. So if you know what function you want to look up about, you can put that in Google directly and it should lead right to the documentation. Like write it in as a function. So if we say format and then include the parentheses, like we're saying the function, that should lead right to the official documentation. But for some, for those using Spider, you can remember you can also just put your cursor there and hit Control-I in Spider, and that'll bring the official documentation up right there. There it is, input and output. And I wanted to pull these up a couple times because these can be hard to read. Nope, that's not the one I wanted. I gave the nicer one. Google recommended not doing that and using the better one. Basically, it looks like they're string format, string format. And format it. Format it, format it. Maybe this one has it. Yeah, everything seems to be trying to forward to the better version. You'll see that a lot too. We'll see this, the better way to format things. Maybe next week. Oh, no, this is showing the better one too. Yeah, because there's a better one that's also called format. Look at simple format in Python. Is everything gonna go to string? Oh, maybe we can do this way. Anybody use W3 schools for script material before? W3 Consortium, they set the standards for websites. The standards for our websites are put together. This, nope, I don't want that one. Well, I was gonna try to pull up the documentation. We'll look at documentation somewhere else. Because there's a better method, a better way to do this that is also spelled format. So Google's just trying to forward to that. I guess for us, this should be enough for anything in your homework for the next 2 weeks until we get to strings and see the better way, which is pretty much going to be currency and stuff. And then if you want to see more digits or less, you just change that digit there. But switch that to a 5, it's going to show 5 digits or 1 digit. I think in most of the homework things, it's going to be just one currency if that shows up. And then that'll get us through choice strings and a better way to do that. The other thing I wanted to do was a quick pass on the math operations, to make sure we talk about those. Some of them should be fairly easy. I'll make a couple assignments and I'll use simple math class notation. Use X's and Y's and Z's. It's a lot easier. A little quicker to type, but when we're programming, don't be lazy with typing. It's easy to spell out big, long variable names. In math class, we use X and Y because we can write X and Y, but if you're a decent speed typer and the time it takes to draw an X on a piece of paper, you can probably type 6 or 7 letters. So typing's easier than writing usually. So we have several math operations. Some of the obvious ones, we can add stuff. Actually, I could do this in the interpreter just to make a point. I'm come over. Oh wait, no, I'm not, because then I can't zoom in. Then I'll print Z. So addition, that should be seem trivial. Add the 2 numbers, get that. Subtraction. I'm going to do it this way. Print. Add. Then print that addition, X plus Y. And if we do it, if you want to do the addition right there, the addition, you have to add an extra step. This might work, but if we tried to concatenate it, since it's in the print method, it'll try to concatenate before it tries to add. So in that case, it added them. If we needed to concatenate into something else, you would just want to wrap the addition in parentheses for order of operations. Make sure that part gets done first. Does everybody remember the order of operations from math class?
Enough.
Yes. Parentheses, exponents, multiply, divide, add, subtract. Probably heard some little poem or something to memorize it. A nice clean one. So usually funny or inappropriate ones are better for memorizing, but obviously the funny or inappropriate ones are not appropriate for a classroom. But they are better for memorizing. You can check Google and see a big list of inappropriate ways to memorize PIMDOS. So there's an order that these things go out in. And anything we do on a computer, there's an order of operations. So whenever we get to logic this evening after a break, when we're talking about the ands and ors and nots, we'll talk about, there's an order of operations to those as well. Then we can subtract, and the rest of our operations aren't really going to get confused with a string, like a plus might, because that's our symbol for concatenation. But it's still just good form to put them in parentheses if you want to do math inside of something. I'm kind of simplifying here. Then we can multiply x times y, print, and the one I wanted to actually talk about is division. So I'll kind of go this far and then we'll talk about division ones. So add, subtract, multiply, those are straightforward. We'll run that. See what happens when we add the numbers, subtract them, multiply them, that's straightforward. The division is different though. It's probably small on the screen there, but 0.323943666. There's multiple things we could get when we divide two numbers, right? I'll write a couple simpler ones on the board here. Oh, something's in the chat room. Oh. Yeah, sometimes I'm a little slow catching the chat room stuff. But division, there's more than one way we can give a division answer. So 52 divided by 13. Those who've had me before probably remember talking about splitting up a card deck with math equations instead of trying to just store a bunch of values in variables or arrays or lists or something. We can skip the storage and just calculate it as we need it. Because if we take 52 cards and divide by 13, the biggest one gets 4. 4 times 13 is 52. So no remainder. But generally we start counting at 0, not at 1. So if we divide 51 by 13, there's several different ways we can get the answer, give this answer. Is well, 13 times 4 is 52, so we can only go 3 times. Subtract 13 and there's 12 left over. So then really that's 13 plus 12/13ths, or then we could find a decimal. We could add a 0, add a decimal, or we could add a decimal, bring the zeros. 13 times that, that'll 9, which is what, 117. Bring a 3, add another 0, and then that process is going to continue. Everybody remember that from elementary school? It'll go twice, minus 26, and it just keeps going until we get tired of writing digits. Or we could just put remainder 12. There's different ways we can get that division answer. And depending on the situation, we might want to give it in different ways. So when I just push the slash there, you know, it just did the floating point division, like what we would get if we put the numbers in a calculator. In our normal calculators. Can you all see the screen if I just do this? Nope, it's too small. That's what I thought.
No, it's in there.
Yeah, it's pretty small. I can't really make it bigger. Maybe the command prompt window. There it is. Is that easier to see?
I just had that.
Yeah, I can read that.
Yeah.
Better contrast.
On those, I can't really zoom in. Oops, not where we're at.
During screen shares, everybody should have under their view options a way to zoom in. So us remote folks should be able to zoom in on whatever your mouse is over.
Oh, that's convenient. I'll just use the text editor. I use Notepad++ because it does actually have zoom features, not just change the font like most text editors. Well, I'll do the numbers on the board. I always use this example for cards. This is 13. That is ring. Oh, I'll just use X and Y. X 13, Y is 51. If we divide 51 by 13, the biggest number we can get is 3 with a remainder of 12. So our quotient could be 0, 1, 2, 3, or 1, 2, or 3. So we have 4 things that could be in the quotient. And our remainders could be 0 through 12. So 13 things that go in the quotient, and that fits the deck of cards perfectly. Ace through king, and if you make king 0, then you don't have to adjust all the other numbers. And then just the hearts, clubs, diamonds, and spades, give them one of the 0 through 3 numbers. And then you don't have to worry about storage for values on cards. You can just calculate it every time you need it. Makes programming things with like card games a whole lot easier. But when we divide those numbers, let's say Z is 51 divided by 13. So if I print Z, oh, I can't zoom in on here. You see that better? Okay, I'm just gonna do that here. If I just go to Python and do the same numbers. So X 13, Y is 52. Then I can say like Y divided by X. And oops, I'm at 51. Make Y equal 51. So then Y divided by X is 3.923. In some situations, that normal calculator result is what we want. That'll be useful. For example, the money thing, then we would format it and just get rid of all of these values. Everything except those first 2 digits that we want to see on a price tag.
When you format that decimal, will it round up?
No, it will not. Rounding is some languages have rounding built in, but rounding is actually really, really easy. So let me pick a spot that would, let's round to a couple things. We also have ceiling and floor. I think I need math to do that. Let me try this. Z equals Y divided by X. This is a relevant question, so we'll do this. So print out Z, we get that. And if we floor the number, floor Z, I'm going to import the math library because floor is not there by default. So somebody already put together a whole bunch of functions and other things that we can work with. They're just not in the core library, so we can bring that library in. That was going to show up very soon anyway. And I'll import the math library. So then I can do math.floor Z, and it truncates that big long number, gets rid of the decimal. Python probably has rounding, but some of our languages it's not included in because rounding can be quite easy. So let's say we want to round to the fourth spot here. I'll do that one first. 3.9230, then our next digit's a 7. So if we use American rounding, so I know there's a couple Latino names, some names that you may have spent some time in a school somewhere other than America and learned the more accurate metric system rounding. So we're just talking about the easy American rounding. Look at the next digit. If it's above 5, go up. If it's below 5, go down. The metric system rounding is more accurate, but I guess that's one of the nice things about Americans, one of the laziness of Americans. We do the easy rounding. So we just look at the next digit. So in this case, a 7 means that should round up to a 1. So what we would do is we can just get over to that digit. So if we do math dot, first of all, we have to make it bigger. We want the 4th digit. So if we do z times a 1 won't change anything. And if we add zeros, that's going to add columns, right? So if we had 4 zeros, that should give us basically the integer over to the one we want. And then if we truncated this now, we'd still have a 0 there. So once we get to that point, what we do is math dot floor, instead of z plus 0.5. Add half to it and then floor. Whoops. Oh, whoops, I didn't reassign that. Let me try that again. Math dot floor. Oh, z equals. Let's not talk about this. Sorry, I got distracted. Didn't think it. I haven't been thinking ahead. So let me pause and answer this rounding question because it's going to cover a couple things. I need to change what's in z so that I can get over to the digit I want. Which I remember seeing things like z equals whatever was already in z times 10,000 in this case, because we need to move 4 columns over. There's a shortcut. This happens all the time in programming. So that sort of thing where we're using the new value, the variable is based on the old value, is shortcutted in pretty much all of our languages. So along with multiplication, we also have multiplication assignment. So times equals 10,000. And most of our programming languages have this. I like to use the term reassignment on it. So z is going to be reassigned by multiplying by 10,000. It's just a shortcut for z equals z times 10,000. Because that shows up a lot. So then we have a bigger version of z. And now I can do math.floor z plus 0.5. And then we have the assignment for all operator for all of our things. So then if I do z divided by that 10,000 we just put there, wait, why didn't that work? Oh, what's in z? So math.floor z plus 0.5. So you can see that gives us the right number, and then we just need to move the decimal over. So if we do that, divided by the 10,000 to move back over 4 columns, we get the right number around it. Sorry, I've done that many, many times, but that's all it takes to round. If you think about it, any of our spots, we just go over to that spot, add the value we want, and then floor it to that integer and bring it, and then come back over that spot. So it's really easy to build a method that does it, right? We could define a function called round that does exactly that. and taking a floating point number. I think I have to hit tab on this one. Then math dot floor F plus 0.5. Well, I got it messed up. I forgot the line of return and I'm over in the prompt. I guess I used to type it in text editors. So you'll see there's problems trying to type the code directly in the prompt. There's situations where we might have to during like a lifetime situation. Usually that's a bad idea. Can I clear this? Nope. But that's the general process for rounding. So I think Python might have a rounding one. We do math.round z to 4 places. Let's see what this does. Nope, Python does not have a rounding one, or R&D. Math.rnd z to 4 places. No, it doesn't seem to have one. So we need to do that little process there. I'll come over here and run and create a function that does it, where I can edit it. So define f floating point number and the number of places we want. This is sort of preview of something we're going to see before too long. Authorize our code, make generic reusable things. And this is what programming languages are built up from, those reusable instructions. And to do it, we'll floater will multiply by the number we want to move, so 10 raised to that power. I should do the other notation. 10 raised to that many places. So this is our exponent. Does everybody remember that in your SDEV 120 class? The 10 raised to some power represents each one of our columns. It's like 10 to the 4th power means we're going to have 4 zeros there. For that example we just did. And then we can floor it. So that float equals math.floor floater plus 0.5. Because then if that next digit is 0.5 or above, it's going to cross over into the next number. So it rounds up. And if it's below it, we're not going to get up to the next number. So it's going to get truncated off. So rounding, we do have to actually build. Then we'll divide that by 10. 10 raised to some number of places. And I'll return it. I'm just going to run that. Oh, I guess I have to type stuff in the script. It's much easier in an IDE in a lot of senses. I'm doing the very bare bone things. So everybody's going to be using different IDEs and things. So let's do that number we just did. We'll call that round function. I guess this is kind of preview mode. These are things we're going to see in Python before long. And I know everybody's had some programming before, so in this class, I usually don't mind jumping around. If you have a question that's going to seem like a distraction, feel free to ask. We'll jump around because it's relevant. We're going to see lots and lots of stuff about Python. We're going to spend 5 weeks talking about Python, and those who are in the 1 to 5 o'clock class with me, you might remember we covered all of Python in an hour on Monday. So it could be much, much quicker than we're going to do it in this class. But then after we spend the 5 weeks on Python, then we're going to look at other languages and do those in an hour. So that this isn't just one single language course. We'll see that after you understand the basic concepts, It'll come together. But it's an active thing, so we're mostly just looking at syntax and the examples and things like that. So let's round a number, 51 divided by 13. And we'll round it to 4 places. Hopefully that function worked right. Let's check it. Nope. Oh. I forgot something silly. Import the math library. And maybe it'll help if I print that number out. You see, sort of the process of how code goes together. There we go. If you remember way back there, quite a few mistakes ago, that was a 0 with a 7 afterwards. So it should have rounded, so it looks like it rounded correctly. I also like to do that stuff in class because, well, notice I have multiple sets of notes here. Whoops. I have multiple sets of notes. So, and I often practice the things that I plan ahead of time so that it goes smoothly. But as you all are probably well aware, what just happened is how programming normally goes. Right? Typos happen. We're like, oh yeah, I forgot a step. This step should have been done first. Because computers don't process in the same way we think. And having prepared examples in class or textbooks that show the finished example or online tutorials that show the finished example, we miss that process. So don't panic if you hit that a lot, because that's what happens when we program. Mistakes happen. We're not machines. We don't think like machines. The biggest problem with programming is overthinking it. Right? We're humans. If you remember hexadecimal, one of the most difficult things about working in binary is it is too simple for the human mind. That's why when we want to work in binary, we work in hexadecimal or base 64 encoding. We make it more complicated because that simplest machine level is too simple for the human mind. We can't quite bring ourselves down that way, down that far. So the most common problem is overthinking things. If you think too hard, remember machines are not intelligent. So if you're thinking too much about it, you're probably doing a lot more than the machine can handle. But like that, mistakes happen, little typos happen. So learning to read the error messages, learning how to detect those issues, how to fix those things when they go wrong. That's what this class is about. And when we see finished examples in textbooks, we miss that. So where were we before that? Does that answer your question, William? And also stretched out enough, did everybody think about why that's always going to work? That to the right
Now you
place.
have a module for next time.
Yeah, and now there is a rounding module. It's that easy. We just move that over, and that's how all of our programming languages are built up. The interpreter, what we actually run it through, it knows what this line means. It knows what define means, return. It knows the keywords. Then we just built this method and extended it up. There probably is one called round, but I gave it 3 tries, couldn't remember what it was. It doesn't take much to write it, so now I wrote something that I will remember what it's called and can use that over and over and over again. So as you progress, you'll end up with kind of your own libraries like that of the reusable codes so that you don't ever have to type that stuff again. But don't panic when things don't work perfectly on the first try. That we're not machines. We think differently than machines process. It takes a couple tries. So the big thing is learning how to interpret this right here. Right? I glanced at that and figured out very, very quickly that it didn't know what name error. That means it didn't recognize something. That's all I looked at. So name error. It didn't recognize something. I saw it was math. It's like, oh, that's an external library that has to be imported. It's not in the core language. So I know how to fix that problem just from 2 words in that error message. learning that is the most crucial step in software development. Learning how to fix the things when they go wrong. Because obviously, if your logic works and it works on the first try, then there's nothing to learn. One of my favorite statements is we don't learn anything from the stuff we get right. It's by making mistakes that we actually learn. Okay, so we're looking at math stuff. So I'll go back in the Python interpreter. Now that I know for certain I can zoom in on this. Can y'all see it with the colors and stuff? I can change the colors in PowerShell.
Oh, it looks good.
Okay. Yeah, PowerShell has all the old Windows command prompts, but they added to it. They didn't take anything away, so all the old stuff works. They added a full scripting language after we studied the tools in Python. That's one of the ones, the last 2 times I did it, it took us 45 minutes to go through all the same tools we'll see in 5 weeks in PowerShell. And they added to it some of the Linux commands, some of the core Linux commands work in PowerShell now. So we don't have to stop and think about, okay, am I on a Windows machine or am I on a Mac? Or for those subtle ones that we do all the time. So there's some commonality on the most basic ones. And for more advanced situations, obviously, some programmers quickly started scripting things and put together interpreters so that we can type in PowerShell and that outputs to Bash. So you can run PowerShell on Linux. So it's one scripting language that'll work on all the systems. So it is a good one to know. So that's why I want to look at that one. But for now, Python. I'll go back to where we were. X is 51 and Y is 13. So sort of splitting up a deck of cards. This is what I use to split up a deck of cards without knowing it. Because we saw if we just 1/ to divide them, we get the calculator. For a deck of cards, we would probably use modulus. So there's the remainder. We divide 52, 0 through 51. So 52 cards, divided by 13, we get some remainder 0 through 13. So that's ace through 10 and then the face cards. And if you make a king 0, then you don't have to adjust any of the numbers. All the numbers just need cast into a string or pull up a file with the appropriate image or something. But we need that integer part. Well, we saw floor, so we could grab the 3 from this number, but there is integer division. If we do 2/, X integer division by Y will give us just that quotient. So that gives us all the options. We can do the quotient and remainder or the floating point numbers and different combinations that way. Just depends on the situation. In a lot of situations, it turns out to be better to have these numbers than the floating point number. But again, it's a very situational thing that we can't really give across the board examples. Remember the first night we drew the hammer and talked about that. There's lots of things we can do with a hammer. It's a heavy object. If they're on a hot summer day when there's a fan blowing, we use a hammer to keep paper from blowing away. Or on a construction site, a hammer could be used as a paperweight to keep blueprints from blowing away. Is that the only thing that tool can be used for? Obviously not. So that's not even the proper use of that tool. And a programming language is the same way. This is a tool that we can do things with. And we'll do things differently depending on the situation. I guess the last one is exponents. So you may have encountered this, those who have seen Python before, we do X caret for exponent. This works in most of our languages because caret is typically the symbol for XOR, exclusive OR. That's the Boolean operator for one or the other, but not both. So 0, 0 and 1, 1 would give 0 because they're the same. Whereas 1, 0 and 0, 1 would give a 1 because they're different. And so it's one of our Boolean operators. And it just so happens that when we apply that Boolean operator to two integers, we get an exponent. That's just a pattern that happens to occur in binary. So we can usually use that. The actual symbol for exponent is two asterisks. So an asterisk is multiply, so our exponent is multiply, multiply. One that should make a little more sense there. So we get a really big number. Actually, we got something different. The caret didn't even work. It truncated it. It got rid of some of our, it didn't add enough values. The caret works if it will fit. So like 4 and 3. Those 4 raised to the third power would still fit in like an 8-bit integer, a 1-byte number. But these 51 and 13 are, we use that as power, that's not going to fit in the same number of bits as 51 and 13. So if you've seen the caret before for that, it's a pattern that shows up in binary, but it won't give you extra bits or anything. So it is kind of restricted to numbers that would still fit in the same number of bits. So squaring and cubing works up to a point. Squaring works to a little. So remember, the exponent is going to be 2 asterisks. I always like to point that out because of that. Some people use the caret, and I've even seen that in reference material before, because it will work for like 4 squared. We can XOR 8-bit integer 4 with 8-bit integer 2. And when we XOR those together, we get the 8-bit integer that is accurately represents it, which is just a pattern that happens to be there. It's not the actual operation. But for some reason, that seems to sneak into reference material. Things that pass themselves as actual reference material. Not official documentation. So once again, always check official documentation first. That's the one that's always going to be up to date, and we'll be able to use it. It's always going to be up to date. Might be hard to read, so you might need to check a few tutorials getting started to learn how to read the documentation. But it's like a lot of things. This is an active subject. Most of the learning is going to be done through practice. That's why every one of our class nights is going to include lots and lots of lab time to just practice these things. So that's the math operation, and then the math library. Oh, absolute value is built right in. That's one. Some of the ones. So like if we wanted the absolute value of x, we get a 51. Or if we take x assignment, multiply assignment by -1. So that shortcut again, that's equivalent to saying x equals x times -1. Now our x is negative, so if we take the absolute value of x, we get the positive number. But not all of the things we would expect to be considered basic are basic there. For example, I always think of square roots. It's like a very fundamental thing, right? That even cheat calculators usually have a square root button. But if we try to do square root of, did I turn that positive? Let me turn x back into a positive number. There we go. Oh, Python can do complex numbers. You do have to import a library, but it's when you install Python, you would have got a complex number library, so you can do the whole a plus bi thing and use square root of -1 and all of that stuff. If you want to like play around with the Mandelbrot set or something with complex numbers, imaginary numbers. They show up a lot in real situations, so you might need that as a software developer, because you probably heard it in math class, and they showed you this big fancy thing that seems just out of nowhere, right? It's like imaginary number, square root of -1. They call it imaginary. It shows up all the time in electricity. And it really does hurt when it shocks you. So imaginary is not the right word, right? Imaginary electricity wouldn't hurt when it shocks us. So a lot of times there's different situations, but one of them in the real world is way back in the day when scientists were first learning about electricity and starting to put together models of physics, they set a 0 level. But then later, we learned out that the lowest possible state is actually 13.6 electron volts. So the 0 is in the wrong place. As a result of that, our measurement system is off by just a little. So as a result of that, there's that discrepancy where numbers could get on the other side of 0. There's some other places where it shows up, but that's one that happens a lot. It's like a labeling wrong on the measurement system means that we can pass 0 when we shouldn't. So things like square roots of negatives show up in problems. So we need those as programmers. So complex numbers can be dealt with in Python. It has no problem with them whatsoever. Just import the library and then your numbers you actually type as A plus BI. You give it where A and B are integers when the library is in there. Just a preview in case anybody ever needs that, mentioning it, that we don't need to get that complicated in here because we're just doing this. I just want to make sure you're aware that it's already built into the language. You don't have to figure out how to handle complex numbers. We wanted a square root of a positive here. This one always gets me in Python because it seems like that's something that should be a basic function. You know, cubed roots or eighth roots or something, that's not so basic, but a square root seems to me like it should be basic. We get the name error, doesn't know what it is. Sqrt, Sqrt, that's kind of standard all over the place. You've probably seen that even before starting into programming. Sqrt for square root. It's not defined, so but it is in the math library. So if we import this set of pre-built functions called math, then we can just ask for, well, look in that math library, so math dot square root of x, and get to the square root function. So that's a really useful one. So since my earlier attempt to look at official documentation didn't work out, so let's use the math library for that example. Math library in Python, which hopefully won't take too long. There it is. And notice the very first thing that popped up is docs.python.org. So that's the official documentation. Or for those using Spider, hover over import math, hover over it and hit Control-I, and it'll pop it right there in your IDE. We go in here just to kind of look at what the official documentation looks like. So this is what it looks like. And one thing about official documentation is it's usually generated. You might remember on Monday we saw that annotation where we put an instruction in the comments that ran. As a program, our script is just a bunch of text, and the Python interpreter ignores comments and runs the Python code. So, but there's nothing stopping us from running it through something else that ignores the Python code and only looks at the comments. So most of our official documentation, we'll see this later in the semester, is just generated. So we put this into the code as a comment, and then we run it through this other thing that turns that into a huge web page with links going to it all over the place, a website, links going to it all over the place, makes it super easy. So we'll see that. So part of the reason these are cryptic is because the actual explanation you get here was the code or the comments in the original code. And then it was just, the website was generated. It wasn't a technical writer sat down and wrote this. They just put these comments in their code, and then they opened up NumPy. I think this is NumPy from the formatting. It's a little customized, but we'll see some before the end of the semester. I think it's NumPy because we can collapse the navigation as opposed to PyDoc. There's different ones, but the people who did it could have adjusted that, but we'll see that later. So like math.ceiling, it takes in some number. So it returns the ceiling of the number, that's the greatest integer next to it. So that was easy to read. What we're looking for is square root, that's what we put in. But I'll just scroll through here and y'all can look at some of them. This is a combination. If some of y'all may have seen that in a math class, N choose K. Is that what the way they went? Yeah, N choose K things. So if you gotta like set up for a dinner and there are maybe 20 chairs and we only need 7 of them for some dinner, like 20 different folding chairs, and choose 7 of those 20. And how many ways are there to choose 7 things out of a collection of 20? Is what that number is. Some of y'all may have seen that in a math class before. It's called a combination, but since our symbol is C, most people just read it as C. Or sometimes it looks like a fraction. 20 things, we're going to choose 7 of them. There's a lot of ways we could do that, right? If there's 20 chairs, how many different ways can we choose 7 of them? So we type math.com, 20, choose 7 things. Oh, I forgot a comma. 20, choose 7 things. Did I do that wrong? COMB. Okay, I don't know why that one's not working. It says it doesn't know it. Let's try something different. Factorial. That's another example. Has everybody seen factorials before? That's a common example in programming things. So factorial is multiply every number up to the one we have. So like 5 factorial is 5 times 4 times 3 times 2, and usually times 1. That obviously doesn't do anything. It just doesn't make any sense to stop that pattern in 2. Okay, that one worked. Maybe the combinatorial is in 310. Because again, documentation is always up to date. Oh, 310, that's why. What version of Python am I? I'm in version 3.7. So let me go back to something that would work. Apparently combinations weren't in 3.7. I know I've used them there before. Maybe I just typed the method myself. But basically, we have that documentation that shows us everything in the language. There we go. I say I have 310 on the MacBook. That page was taking so long, I was like, maybe it'd be quicker to pull that out. Oh yeah, so there's no combination method. Like all of our all software that we're used to, programming languages do get updated and improved. So whenever 3.7 came out, which I haven't updated that in a while because I've got this project that's been going on for years. Some projects get really big and stretch on and on and on. I've been there, so floor, we saw that one. The largest answer equal to it. Find the sum of a bunch of numbers. And here, the parameter it's expecting is an iterable. So that means a list or something. And well, this doc site is nice because just because that might not be really clear, they went ahead and did an example. So sometimes you'll find that. But you want to make sure and look at the official documentation. So the GCD, everything, remember that in math class, greatest common divisor. Usually we use it to find the common denominator to work with fractions. It's probably where you learned that in elementary school, and then your math homework with that. There'd be a really easy example like in math classes, like 2s and 3s. Or something that can go, numbers that would split down really easy, and then homework would get more complicated. I started to think about the lowest common multiple, 2 and 3, and then 6, and then you get in homework and you see numbers like 17 and 39. You have to find a really complicated thing. Everybody's seen that. Similar things with greatest common divisor, which is the opposite. That's the number we would multiply by to find the common denominator. So if we know that so the lowest thing that numbers have in common. So like math, GCD of 325 and 27. Is it 1? They don't have anything in common. Math, the greatest common divisor of 320, what is that, 5? So a 1 and a 27 would have at least a 3 in common. I just added the digits together. If you add the digits together and it's divisible by, the sum's divisible by 3, then the number is. But the general point there is that documentation. So that's one that you might want to look at. Look through there at the math one and look at things you know. That's going to be one of my recommendations for that time to ninth. Exponentials, logarithms, powers, and look for things you might recognize from math class. There's a lot of complicated ones, and in general though, at this point, mostly use something like that to get used to reading that documentation. The way I've been saying it lately is it kind of seems like the people who are really, really good at writing programs and put programming languages together usually aren't so good at writing English sentences telling you how to use the programming language. So they're good at Python, not at English. Better at Python than they are at English. So sometimes it's hard to learn to read documentation. So one of the steps of learning a new language is look at the documentation and figure out how to read that, how to make sense of that. So that's gonna be one of my recommendations for lifetime. We got some other stuff to talk about. That's the simple formatting numbers. We'll see a better one soon. And I remember when I tried to pull that up as an example, that Google tried to correct it to a better way to format automatically. Like, oh yeah, don't use that one, use this one, which we will see in module 3, I think. Either module 3 or 4, we'll see the better way soon. But that simple way will get us through for now, the math stuff, and you're gonna want to just play around with it to get some practice and get used to it. And I would definitely recommend looking at that math library on there when we get to lab time. But we've got some other stuff to talk about, and it's probably a good time to take a break, right? We've been talking for a minute. Does 10 minutes sound good to everybody? I see head nods here in the classroom. So 7:23, we'll get back to it at 7:33. Oh, something in the chat room. Is there a question? Oh, okay. Just an answer. Where's my stop recording? Stop recording.